Another very interesting comment that was made is as we grow in our technical world of robotics and different types of technologies that will replace the need for a human uh, worker to do the work, um, there is a little bit of truth in that when it comes to 3D printing, in that it eliminates a hands-on person that's actually building that part. It's now being done by a machine. However, there's a big flip side, and I call it the invisible side of 3D printing that people don't see. So let's kind of walk through something like this. This is something we just recently did. So we started out with our original cast northern pike head, and then we scanned it in. So you have the cost and the time of a guy scanning it. What does it take to scan something like this in? Oh, probably can be done in less than an hour. Then we have to take and we have to do the inner mouth, and so we can't get in there with our scanner. It's too large. So what we have to do is we build a silicone mouth plug, and then we pull that out and we have to scan that and make that all work together, come together, so we can get the inner mouth detail into the model so it's there for you as a customer, consumer. The process then, once you have a scan, this is again a big misconception. People think, oh, well, we have a scan now, we're ready to go print. No, it doesn't work that way. That scan needs to be cleaned up. What that means is the original scan will have an accompaniment of what's called surface noise, meaning anomalies on the surface that need to be cleaned up. It has to be done digitally on a screen by an artisan. And on something like that, like this piece here, that could take as much as 2 days of time for an artist to grab this piece and get the detail all plugged in real well, make sure that there's nothing that didn't come out right in the scan. And it's a very time consuming and laborsome part of the project. So, what I like to say, it's kind of a trade off in that, yeah, we're not having somebody stand there and actually make the part, but you are having all this behind the scenes stuff that nobody sees that goes into this to making a model. A lot of time, a lot of money, a lot of effort by several people. Then the file gets made, and then the file has to be inventoried. It has to be a bunch of build plates, and we're going to show that to you a little bit later on. Um, the model is sitting on inside of a printer at whatever angle we decide to place it in there, and the build plate is above in the printer, so the model is hanging. We're fighting gravity, but not gravity pushing down on the model. We're fighting gravity that's pulling the model away from the build plate and hanging the model. Basically, the model is hung by all these structures, which look like little industrial trussels, or things you'd see on a construction site coming down, supporting the model as it's being made. That the machine will do that to a degree for you, but you have to also um, learn just through experience where weight will be and where there's the possibility of something pulling too hard and the model starts to distort. You start to get a shift in the model. You start to get things that don't look right. And in most cases, you always have a casting or two that you have to make on the machine and fine tune all that. You set it up the best you can. You add in whatever you want to add in to try to support your model. But at some point, you just have to test your theory, make a part, look at it, and say, yeah, everything came out good. And that doesn't happen too often. I can't I can't think of too many times where we've just gone through the entire system, printed a piece, and pulled it out and go, yeah, it's perfect. It worked perfect. There's always something that you go, oh, shoot, I missed this. I've got to, support that item here. That part of the model has to have better support. And so it's a process of just fine tuning the whole thing. Again, that's time. It's time. It's hours. It's not a couple of minutes. It's hours. And so anybody that thinks this is real simple and is just like pushing a button and everything gets made, there is some truth to that once you got it all dialed in and everything's going well. But there are a lot of elements to it that are very detail oriented, and you have to really pay attention. The machines themselves are very finicky. They've got to be perfectly level. There has to be a certain temperature in the room or in the machine itself if it's a heated machine, and just all sorts of little detail anomalies. And when it doesn't work, it's not like, oh yeah, I think I need a new carburetor. It's kind of a, here we go. Let's try to figure out what's happening now to try to remedy the problem so the machine is back operational and producing prints the quality that you'd like. So there's a lot to it, and it requires our company right now has, oh gosh, one, two, three, we have probably four um, pretty full time people. No, actually five people. A couple of them are part time, but five people that work on just the 3D printing aspect of our company. And then we have other vendors that are just, sole propriety vendors that we hire to do printing for us. If I were to add it all together in a big nutshell, we're probably up to 10 people that just work at various aspects of the 3D printing uh, element within our company, and so there's a pretty big workforce that just is dedicated to the 3D printing aspect of what we do.